In this section, we're going to learn about data persistence and data management because it's something that a lot of people really struggle with when it comes to game development. And that's partially because it's just so easy to save data off in any way that you want. It's really easy for us to add data to just about any type of object when we're writing code in C#. Like you saw with our coins, we added a data for coins onto our player just by adding a coins field. Remember, let's go open up our player and take a quick peek at it. We just added this coins, technically it's a property with a backing field, but we added this coins property and we just keep track of how many coins our player has right there on the player object, and it seemed like it kind of worked. But you probably noticed that when we actually start playing and go from level to level and stuff like that, that our data is getting reset. Let's go check it out real quick and talk a lot more about this, and then we'll go into some really interesting solutions. So here I can come over, pick up some coins, go to my next level, and my coins are back to 0. And if I go back to level 1, my coins are still at 0. I go pick up coins, and my coins get their values again. So the reason this happens is pretty simple. It's because this player object with the number of coins that we have, let's go expand out our debug mode here and take a look at it. Our player with the number of coins, which is right now set to 6, and if I jump up, it'll be a 7. That player object is going to be destroyed and a new one will be created when I go into level 2. Let's go take a look. Go into level 2 and well, we've got a totally different player object. In fact, I can make this even more obvious by going to my level 2. Let's go into scenes, go to level 2, and I could do something different to this player, like maybe change his default color, or let's go out of debug mode into normal mode, and I'll just make him like a 50% larger. So on level 2, we've got a big, fat, tall player, and on level 1, we have a smaller, well, smaller scaled down normal scale. So here's my level 2 version of the character and the level 1 version. So we've got two separate objects. It's not the actual same object being recreated or being reused, even though it shares a prefab. It's actually two separate instances of that object. So what we need to do is get our data to persist across different versions of our character. Let's reset this back to a 1 and a 1, and I'll leave the position there. And we'll talk a little bit about what our options are here. First, we could just maybe keep a player around and keep a player object that we keep from scene to scene and just move them around. But you're going to notice that that'll cause some issues as your game gets bigger. If you got something small and you've just got one player object, it's not too difficult to keep them around and keep them from scene to scene as you load in, maybe using something like the don't destroy on load method, which will keep an object around even when you load into a new scene. But I found that in general, there's a better way to do it, and the easier way to manage data and the easier way to make it so that you can keep building on your project later, do things like saving and loading, having multiple players and all that, is to separate that data off of your player or separate it off of the objects that care about it into a system that can just persist that data, give you back a player, or do all of the things that you might want to do in a nice clean way that doesn't kind of bloat and make your player script get nice and big or cause other issues along the way. So let's start by opening up our player script. And the first thing that we're going to do is create a new player data object. We're going to create a new class that will store data for our player and store this coin info there and then kind of wrap that or hide it. We're going to do this in a way that seems like it's not changing anything at all, and then we're going to do a little switch and you'll see the magic kind of appear. So let's start by creating a new class. Let's do this down at the bottom of our player script, and we're going to put in a value for coins, and we'll add in a value for health as well. So I'll go down to the bottom with Control and End. Go down and just start typing. We'll put public class player data. Inside of it, we're going to put a public int coins, no T in coins, and a public int health. So now I've got a public class player data with a coins and a health value. I'm going to copy the word player data, go all the way up to the top of our class, and right here, right above our coins, actually, we'll put a private, or we won't put the word there. We'll just put player data underscore player data. And let's initialize it to have a new value at start. So we'll say equals new player data. This will give us a brand new blank player data with a 0 for the coins and a 0 for the health. Now, when we access our coins, instead of just directly accessing this integer, let's modify the coins on our player data object. To do that, we've got a couple options. I could write this out as a big property, or I can use my expression body property syntax to simplify things down. And after the get, instead of having it be automatic, we'll add a lambda statement. So that's an equals and a greater than, and we're going to have it get back or return back the player data's coins. So to do that, let's do underscore player data dot coins. So now this coins value, whenever we read it, it's actually going to read from player data, and it's going to read its coins value. Kind of confusing if you're not sure what we're doing yet, but don't worry, it's going to make a lot more sense really soon, because we're going to split this player data off so that it's not just part of the player. We can see it other places and rebind it and stuff. So we've got our get method. What if we want to set it? Well, for the set, we need to add a lambda statement as well. We'll do the equals and greater, which means that when we want to set, we just want it to run the code after this lambda statement. And that's all this is doing here. When we read this, when we read the coins value, it's saying, hey, when you try to read this, just return back out this value instead. That's what this weird little get syntax does. This private set means that only set it from inside this class. And when you call set, you say coins equals something, then instead, technically underneath, do this code, which is going to be player data dot coins equals, and here we use the special magic keyword value, which is the one that's being passed in here. You can see that it's blue because it's a kind of a keyword or a special word. So this has now wrapped my coins data in this player data. Let's save, minimize our code editor, and then go back into Unity, and we should expect to see exactly the same behavior. That's what we're looking for right now. And then in the next section, we're going to figure out how we can split that off and have that player data persist even when our player doesn't persist. So let's see. We play, run over here. I've got 0 coins. Yeah. Run over here, jump up, get some coins. Go into the next level, no coins again. Go back over here and got my coins again. All right, so we're going to stop playing and we're going to commit this to Plastic again. We should have exactly the same functionality. We've just added a player data layer. We haven't actually taken advantage of it. So we're going to say that we added player data layer to the player, but didn't hook it up completely yet. And we'll check those changes in.